So we're looking at the series as a way to take people who have business education, some level of technical expertise, but are not deeply into the technology, and give them an overview of what is the technology, how can it be applied to business, and and some use case applications. My background is that before I joined HBS about 15 years ago, I was an entrepreneur. And back in 90 or so, when cellular phones first came in, I ran a company that created the first system for roaming, then created a company that did the first internet commerce, and since then have kept up with big waves of technology that have come in. It feels to me like this wave of technology, centered on AI, is the one that's going to cause the most change, and that's a big statement, considering that in that group is mobile and the internet. And so, while all of these technologies build on each other, I thought today I'll just give you a sense of what the technology itself is, but also give you a sense of how it works. And then my colleague Hans-Peter Feister will give us a couple of examples of LLMs at work, ChatGPT at work, and we'll spend a few minutes talking about what to expect from the technology. If you have questions, please put them into the chat and we'll try and answer them as we go along. But this is an introductory session, so we'll just cover the basics. For today's discussion, as we go through it, trying to get that. Today's discussion is the foundation on which we're going to move forward. But the next 5 sessions roughly are going to be looking at specific businesses. And then we have Professor Jackie Lane, who is going to work with us to apply ChatGPT in particular to groups. So far, most of what people have done is use it individually, and yet most of business is a team sport. And so what we're starting to do is look at this and say, how can we actually use it in teams, and what are the different models of doing that? We're then going to look at a more strategic perspective, from the perspective of someone running a company. How do you build a company on this? What are all the functions that come in? We're then going one step deeper and saying, if you're in marketing or accounting or finance, or if you're in strategy, how can you start to use ChatGPT or large language models? Then the following session will be on process implementation. So how do you educate the team? How do you make changes in the current systems? What are the typical problems that you're going to run into? And then the final session will be stepping back a little bit and saying, what are the ethical concerns? What happens to society? There's a lot of discussion about this, but trying to give us some sense of how do you make sense of all of that? Is the world going to end because of AI, or is it just going to be a utopia? And how do you pass that difference as we go forward? So this is a few weeks ago, as I was thinking about this talk, I asked ChatGPT to do me to tell me what effect AI is going to have on business leaders, and then asked it to do it in the form of a rap verse. And this is a typical use case for a lot of people who are just experimenting with it. You go in, you ask it a question that you've been pondering, and then say, put it in the words of Taylor Swift, or do it, as if it were a limerick. And it does an absolutely remarkable job of taking something like this and completely doing it. Now I could say, take this and put it in a bebop structure, and it will do that. And so there's something magical about the technology itself, and it will also create complete nonsense. And so, as you look at it, all of us have sort of wondered about, how can I use this for something really serious? On the other hand, you have different perspectives on it from someone like, say, Sundar Pichai, the CEO of Google, who has said in a number of interviews that this is more profound than fire or electricity. That's a pretty broad statement, especially a statement from the head of a company that in many ways defined what Web 2 is all about. This is Henry Kissinger, after spending time on AI and in the book that he wrote with Eric Schmidt, talks about this being a change as big as the Enlightenment. Now, for those of you who are up on your history, you might recall that the Enlightenment is when the world, at least the Western world, moved from looking at the world as, as being run by God to systems that included or that gave power to humans. So, the form of government, capitalism in its very early stages, and so on. So really the underpinnings of our society. And some very thoughtful people and at least qualified people talking about this being a change that's as big. So if you switch to ChatGPT itself, it's by far the fastest disseminated app in history. So the left chart shows you how quickly it went to 100 million users, 60 days. A number that's pretty much unheard of. We've seen something like Netflix take 3,500 days, and then progressively other platforms that have spread across the world taking less and less time. But this came in November 30th, and then it went viral in a form that we've almost never seen. And some of that is because of almost the immediate magic that you get. You go in, you ask it about anything, and it comes back with an answer that is surprising. Sometimes it's true, sometimes it's not. But it's surprising in terms of its ability to talk. And in some ways, one of my colleagues was looking at this and said, it tells me things as if it had an English accent. It comes in there and it says this in this very polite, direct way with perfect syntax. And so I'm inclined to believe it. I'm also amazed at the way it can summarize things, change them in any way I want. And it's that pseudo-humanness that creates the power through the interface. So if you step back a little bit more and think about ChatGPT in the context of what's been happening with AI, this is a chart that shows how long different kinds of AI have taken to reach human performance. That itself, the fact that we're looking at a chart like that itself is quite stunning. But you take handwriting recognition, speech recognition, image recognition, reading comprehension, all of these things. But what you'll start to see is two things. One is that they're all at or have exceeded human performance. And the second one is that the lines are getting more vertical. And so from the time you start to create it to the time that it reaches and exceeds human performance is getting shorter and shorter. And this chart ends in 2020 and 2020. And so as we go forward, we're seeing more and more of this. And this kind of analysis is then fueling some of the concerns of what happens existentially to us. In this talk, we're not really going to be spending a lot of time talking about AGI or artificial superintelligence. What we're really going to be talking about much more is what is the current technology? How does it work? And what are the applications of it? And then through the series, we'll do that till we go to the end. On the right side, I have the GPT-4 capabilities. And in the LSAT, the GRE, the SAT, it's at the top decile of performance. That itself is pretty remarkable. I've seen some articles in which people say, well, on writing, it didn't quite do it. And you look at that and you say, well, it's at 54% percentile of the people who are taking GRE. I mean, that's a pretty remarkable achievement as well. So the other thing that as a background that's worth noting is that this is largely a business-led revolution. It's not led by government or academics. So if you look at the chart on the left of notable AI systems, most of the systems that are defining where we are today were created from 2012 forward. So if you look at the period from 2012 forward and look at the red bars on it, what you'll start to see is that most of them, especially in the 2015 to 2022 period, almost all of them are created by businesses. Then if you look at the talent distribution, what you'll see is that most of the PhDs, new PhDs in artificial intelligence, work for industry. And so what you get is industry becomes and business becomes the center of the world in so much of this. So as you go forward, you have Andrew Ng, who talks about this as saying, while he hasn't been somebody who's been at the extreme in terms of saying this is going to destroy humanity, the part that he keeps emphasizing is that this will change all industries. So if you're in business, you should be paying attention to this. And then you have someone like Sam Altman. Sam was in my class the previous year. And one of the things he said was that the change that is going to happen in terms of the fundamentals of business, the cost of labor, the cost of energy, the cost of electricity, the cost of computing, all of these things are going to change in ways that we haven't got a good sense of it. And so today, let's step back in and say, what are the underlying technologies and what do we need to know about it? And in the same way that we don't really need to know the physics of an internal combustion engine or of electricity to understand what they can do for us, but we still need to understand some things about it in order to know what its limitations are and to have some judgment on, as it progresses, the pace at which it's going. There are some things that we need to understand about the technologies as business leaders. And so I'm going to start with deep neural networks and then talk about the large language models. And in this process, to try and get this done at a reasonable pace, there's a lot of simplification and generalization that I'll be doing to give you a sense of what it is. And so just, I want to just acknowledge that. So the first thing I think, and the first concept or set of technologies that are worth understanding at some level is supervised learning and deep neural networks. And so what this is fundamentally, and this, Geoffrey Hinton was one of the key pioneers in this. And the big breakthrough on this was that artificial intelligence before this was, and a lot of software programming works this way, was that we will give you the data and we'll give you the rules, you give us the output. So it's really an automation of something we know how to do. And what happened with neural networks was a change in that paradigm to where we said, we'll give you the input, we'll give you the output, you, computer system, figure out what the rules are. So in this example, what you're doing is you're taking a picture of a bird, you're running it through, you're taking the pixels of it, running it through the input layer. And then in a typical neural network, you have a series of what's called the hidden layers that are doing the analysis. And then there's an output layer. And the output layer is saying, this is a bird, or it's a dog, or it's a cat. It's trying to make some judgment on it. And one of the things that comes up very quickly is if you try to define the rules for what is a bird. Imagine you're telling a child what a bird is. You could say birds fly, but they don't. Airplanes fly too. And so as you go through each of the characteristics of what is a bird, you end up with a lot of difficulty in describing what is a bird in a generalizable way. And what these networks turned out to do was to be able to generalize across large numbers of examples in ways that we don't fully understand, but do that at an extraordinary way. Now you could say, well, humans could look at birds and figure out what a bird is, but you can't do that millions of times, or you just don't have enough time. And so once one of these networks does this, you can then run millions of examples through and make that work. So I think the first thing to just recognize is that the way that these systems work is we define the structure of the network, but the way in which the functions get done within the network is done by the network. And I'll show you an example of that in a minute. So As we go ahead, this is the same network, and it's looking at a cat. And this is what's going on within the layers. So as you look at the different layers, what you find is, if you were describing a cat, you might see something like pointy ears, you might say something like tail, four legs, and some of those features show up in the layers. So at the beginning, you might see outline of a cat. And then as you go along, you might see there's something about the pointiness of the ears. You might see something around the way in which the eyes and the ears relate to each other. But then in certain layers, you don't see what the network is doing at all. And sometimes you go in and the background is taken out in some of these things. But as you look into it, what it's trying to do is define a notion of what is cat. What does catness stand for? What's also happening here is that it is looking at a cat in a very different way that we look at it, even though the network is trying to, in some ways, mimic the human brain. So if I take this cat and I put some noise into the system, we can still recognize it as a cat. A neural network might say, no, this is an ostrich, because the way it's processing data is very, very different. The other process that's occurring here is that it runs through this system fundamentally by putting weights on each of those nodes. And then it comes out with a projection. So in the last example, it said there's a 60% chance it's a cat, but it also said there's a 20% chance it's a dog. And what the system does then is use a process called backpropagation that says, I know it's a cat. You said there's a 20% chance there's a dog. Go back and adjust all the weights so that you're absolutely sure that it's a cat, that the weighting on the cat goes up, because I know the answer to that question. And so it goes back in and keeps adjusting all the weights to become better in that process. And in some ways, that was the big breakthrough around 2012 that made these networks so powerful. So if you look at this picture, I can't tell if it's a cat or a dog, but the network will go back in and it has some way to do that. So a different way to think about this is a very simple function, a mathematical function on the left. And as it gets more and more examples, so with 10,000 examples, what you get is a line that looks like a straight line there and is not a very good predictor of that mathematical function. With 100,000 examples, you get something that says, well, there's a little hump in the middle. With about 1 million examples, you get something that starts to look like the function. And with 10 million examples, you get the whole thing. But what's happening in this process is it is taking more examples and spreading the weights across, having more parameters to play with. And so one of the things you often hear about is how many parameters does the model have? GPT-3, I think, had 175 billion parameters. And so through all of this, what you start to get is around 2012, with ImageNet coming in, was the first example in which one of these deep learning networks, and about that same time was also for translation. But it started to exceed human capacity. So this was a competition that's been done every year. And sometime around 2012 was when we saw big increase in performance because of this kind of technology. And then since then, it's been increasing to now the error rates are about 3%. What's also true in these networks is that you can take a network that was trained on something else. So in this particular case, you take a network that's trained on, fire trucks and broccoli and fish and teapots and tigers, just a collection of different things. The model that was created from that is in the public domain. And then a group of researchers, some from Harvard, some from Google, got together and they looked at, and they used the same model in the public domain to look at retinas of people who were either had or did not have diabetic retinopathy. And then they retrained it using 130,000 images to predict the level at which it had that particular image of an eye would show signs of retinopathy. And at the end of that whole process, it was better than generalist doctors and probably a little bit worse than specialists. And so, the difference is that once you have a system like that, you can now start to work through and scale it completely. So in parts of the world where you have large percentages of the population, like India, where I come from, who don't have access to doctors, this is something that can be cured if it is caught early, and the person could go blind if it's not caught. And so you can have a system like this that scales completely because the knowledge that you've gained can then be spread. And that's one of the great powers of this technology. So if you go from that, we've got a series of advances in the technology. And with that, you have a whole variety of incredible promise. So creativity, you've seen this in creation of music, creation of art, in productivity, all of writing, coding. We're seeing 30–40% improvements in coding in just the few months that these products have been out. Personalization, you can completely personalize education. If you look at what Khan Academy has been doing, it's remarkable. In discovery, people are looking at this for medicine, for material sciences, and so on, for security, for monitoring everything and trying to decide when there's a threat, when there isn't. But at the same time that you have this, the exact flip side of that is also true. The same technologies then get used at scale across the world for changing, for creating bias, for misinformation where we don't understand the truth. So the Center for one of the centers in California just put out a statement saying they believe that the 2024 election will be the last one in which humans decide what the outcome is, because there'll be so much misinformation generated by systems like this. Loss of jobs, inequality, security threats, all of these things come in. And so as a company, when you're going in, particularly things like bias, like hallucination of information, you have to be careful about how these systems get put in, because it's very different from previous systems. So how does it work? GPT stands for Generative Pre-trained Transformers. And fundamentally what it's doing is just saying, given a sentence, given a text so far, what should the next word be? And so if you take a sentence like, the best thing about AI is its ability to, and it's taking all the words in the English language, taking the billions of words that are in its training set, and it is creating relationships between all of these words to say that this is my prediction of the next word. And it doesn't always use the highest prediction, something called a temperature setting in which it goes through. And so it can give you a different answer every time. But fundamentally, that's the core of the system. But in some ways, that greatly oversimplifies the power of what it's doing. So if I ask you to end the prediction of something, if I say, Donald went towards the house and I have a blank in it, you could fill that blank in with Donald Trump, or you could fill it in with Donald Duck. And these are very different contexts and very different sentences. And so for you to understand, you have to understand the whole context in which that sentence was spoken. So the way that this gets created is you take a huge amount of unlabeled text, because in the previous example that I gave you of, is this a bird or not? And I know the answer and I'm training the system that way. It's very expensive to get labeled text of millions and millions of anything. And so what you do is you take all of the text and then you just hide certain words because you know what those words are going to be. The model does its thing, as we said before, and it predicts what the words are going to be. Then you calculate through the back propagation and you say, go and improve yourself. And so the model then changes the weights in the process and keeps improving through this process. But in order to do that, it first has to take words and convert them into numbers, and it does this through a process called tokenization. Now, if I looked at 50,000 words in the English language, GPT-3 used about 50,000 tokens, but it could process about 2,050 tokens at a time. So roughly 1,700–1,800 words. That's about a long article. Now, back maybe 100 years ago, a Russian statistician showed that if you had two words and you were predicting the third, you got sort of reasonable sounding things. And so one of the reasons why this is so powerful is they're looking at thousands of tokens at one time for every sentence. GPT-4 can do 32,000 tokens at a time, a small novel in that process. What it's also doing is a concept called embedding. And what it does when it embeds something is it takes the words and it tries to find the meanings of the words, or at least the closeness of meanings. So if I took letters, if I took numbers and that were handwritten, I'm trying to say all these twos sort of look the same, even though they're two on the other side, all the ones kind of fit together. If I was doing words, I might say something like a crocodile and an alligator seem to come together in the same context many, many times. If I'm doing images, I do the same thing in this process. And this embedding process is something that the computer is doing to say, these are things that are more likely to be together than not. And when you look at the way that it does the embedding, one of the things that scientists are starting to see now is that there is a deeper understanding of the structure of language, but also the structure of reality. And so that's one of the really promising things about where we're going with this. And then the final step here is attention. And attention is a technology that was created by researchers at Google back in 2017. And what it does is it fundamentally says, how does each word relate to the other words? Which are the important words in the context of a sentence? And so in this case, the promise of a large language model is that and that has the highest weight in this process. What it also then allows is that the entire sentence can be processed as a whole bunch of words, as opposed to having to do it sequentially. And what that does then is it allows the whole process to scale. So for example, if I took Abraham Lincoln was born in 1809, the process then starts with deleting the word born. The system has to guess that. But after it does that, I can then take away the word Lincoln and it works through. And within that, it's creating the attention that says that Abraham is really important for Lincoln, but was is not such an important word and in is not such an important word. 1809 is important in setting the context for this. And so it's putting weights on all of these different things. What's also interesting here is this notion that comes up that, is it just autocomplete? So if I take the sentence, the trophy would not fit in the suitcase because it was too small. What you have to then say is, what is the it referring to? Is it referring to the trophy or to the suitcase? And in that context, if you think about that, you'd say the suitcase has to be too small because otherwise the trophy would fit into it. And for the model who knows nothing and is just looking at a pile of numbers coming through, it has to have some sense that there's something that has size, there's something that has to fit in. The trophy has a certain dimensionality to it. There's a reality of the world, the model of the world that it's building. If I took the second sentence, which is the same sentence with the one word changed, the trophy would not fit in the suitcase because it was too big. Then the it in this case is referring not to the suitcase, but to the trophy. And you can see this when you apply these two sentences and have them translated, because French, all the nouns in French have a gender. And so you know exactly what it's referring to there in each of these cases. And so as people are looking at these models, they're finding a deeper understanding of the world. I'm going to just end with a couple of really quick observations. One is the notion of foundation models. Sometimes the words are used interchangeably, but what we're starting to see is a set of models that are being created. So you can have a GPT-like model that's created with language, and then on top of that, you fine-tune that. But the bulk of the work, the hundreds of millions of dollars that are spent creating that, and then you just put your piece of it on top. So it's your company or dentistry or biology or something that's very specific, and you train the model that's already been established to deal with your kind of information. Then there's this notion of models of the world, which we just went through. One of the more intriguing things that's happening recently is as these models get bigger, they suddenly seem to generate new behaviors that we couldn't see before. And then the final thing is multimodal models. So models that are using not just text, but also sound, that are using pictures, that are using other ways, just as we do as humans. One thing to point out is that one of the big innovations that's occurred that ChatGPT is brought to the foreground, but generative models in general have started to do, is that in the past, the way you dealt with speech, or the way you dealt with translation, or the way you dealt with image recognition, these were all different methods. And so the progress in each of them was on its own lane. And now with these models, you can do a lot of these different things using the same underlying technology. So any change in the technology affects all of these things together. And so the pace of change then goes up quite a bit. You see emergent capabilities. There's some debate about whether this is just because we're measuring it differently or not, but you have a model that's fully trained in answering questions in English, and then when it reaches a certain size, it can answer questions in Persian, and so on. And then the final part of the fine-tuning is you get these models, and what OpenAI did was, in order to stop them from doing things that are harmful, or at least contain that, they started to fine-tune the model using human feedback. And that was a big step that contained a lot of the harm, but it's still an imperfect technology. So I'm going to end with this example. People often thought about AI as it's a statistical model, and so it doesn't have a sense of rules, it doesn't have a sense of logic. So this is something that I put in to ChatGPT a couple of days ago. And in it, you're saying there are two people, a cat, a basket, and a box in a room. Jane puts the cat into the basket and leaves. Robert takes the cat, moves it into the box, and then he leaves. They come back. Since the cat has been moved, what do all the participants in the room think? And so you can kind of work out, but you have to have a model in your head about how this is all working. Jane's putting it into the basket. Robert is taking it from the basket, putting it into the box. So the cat's going to be in the box, but Jane doesn't know that it's there because she wasn't there when it was moved, and so on. So when you ask GPT 3.5, when they come back, what do they think? It gets Jane pretty right. It says, when she comes back, she expects the cat to be in the basket when she returns, but it gets Robert completely wrong. It gets confused with this process. It says that he puts it in the basket. He expects the cat to be in there, and it's completely confused. And once it does that, then it confuses itself about what they're thinking, how they work, all of those things. It also is confused about what the cat is thinking. So, it says the cat finds itself, it's not aware of the actions of Jane and Robert, without the understanding, the physical understanding that they're acting on it. So if it was working on it, it would know that these things are happening. When you go to GPT-4, you end up with an almost completely accurate description of what would happen. And in fact, it says Jane thinks this, Robert thinks that, and the cat, being an actor of its own actions, knows if it's climbed out of the box. So the cat knows that it's under the bed. And then it goes on to say, well, the basket and the box don't think anything because they're inanimate objects. And so that's a very different level of sophistication of a model of the world than we've seen before. So I'm just going to end on this, which is, I asked it, Jamie Dimon, CEO of JP Morgan, had a talk with analysts, and I asked him, what did he think about big tech and fintechs, what banks should be, what was his assessment of it? And ChatGPT said that what he said was that they should be embracing innovation, leveraging technology, a very logical thing for Jamie Dimon to have said. And it says it in such a way that I actually feel like I should believe it, because this is the kind of thing Jamie Dimon should have said. What he actually said was that we should be scared shitless. So I think that the combination of what ChatGPT said and what he said is a good way to think about GPT, which is it has tremendous potential for leveraging technology, and we should be scared with its potential. over here. So let me turn it over to my colleague, Hans-Peter Fester, who's going to show us a little bit of a demo and then move from that into talking about where we go from here.
Thank you, Shikhar, and welcome everyone. So I'm going to start sharing my screen. Hopefully you can see this, and hopefully you can see my slides. My name is Hans-Peter Pfister. I'm a professor of computer science at the Harvard School of Engineering and Applied Sciences. As of, 2 or 3 years ago, Shikhar, I believe, we are now neighbors. We have a brand new building in Alston, so please come visit us. It's actually open to the public on the first floor, and it's absolutely spectacular. So very happy that we moved there. Shikhar asked me to give you a few demos of ChatGPT, and I thought the best way to do this to think back, what did I recently do myself? And what are the kinds of things that I use ChatGPT for? And so I'm going to just show you a few examples of how I use it, which is by no means to mean that this is an exhaustive set of demos, or that I'm going to demonstrate all of the capabilities of these models. But the first thing that Shikhar very articulately pointed out is that these models are, of course, great text generators. So I'd say most of the time, I use them to generate text. So here is an example. I wanted to write an email for a student who did not submit an assignment on time and now asks for an extension. Believe it or not, that happens at Harvard. And I don't want to grant him that extension out of fairness to others. All right, so let's see what ChatGPT does. This is the quote unquote free version, right? So this is the 3.5 model, not GPT-4 yet. And as you can see, the email is very articulate. Appreciate your honesty, etc., etc. However, after careful consideration and assignments are given, then it's a long explanation. Quite honestly, this is better than what I had drafted, right? So I would actually probably take this answer and I would adjust it. But I wanted to push the model a little bit. So I add, please be more curt and decisive, and see what the model does with that instruction. And so now it makes it, first of all, shorter, and it's also a little bit more curt. After careful consideration, I regret to inform you that your request has been denied. The deadline was clearly communicated, etc. So it's definitely taking instructions. And I think coming back to what Shikhar says, this sort of counters this notion that these are just statistical parrots, right? There's something going on in this model that lets it change the tone of the generated text quite substantially. And now I say, no, now be very brief, maybe even cynical. Not that I'm ever cynical, but here it is. Your request for an extension has been denied. The deadline was clearly communicated. Granting an extension would be unfair to other students, period, right? Please manage your time better in the future. I might delete that sentence when I send this. Anyway, so the point here is that these models are actually able to change the responses based on the prompting from the user. And again, this is just the base GPT 3.5 free model. Another example of what I use the model for quite a lot is summarization. So I know that Microsoft wrote a paper about GPT-4 called Sparks of Artificial General Intelligence. And its PDF is available online. So I give it the link and I ask it to summarize this paper for me. Now, in order to do this, you actually need to use a plugin because I'm asking it to read a PDF. And there's a couple of plugins. You'll find them in the plugin store under GPT-4. So when I'm doing this, it will actually call one of those plugins, Chat with PDF in this case, and it will try to access the link where I, found the PDF online. So it's used that plugin, and then it's starting to summarize it. And it's actually a very good summary. I've read the paper, of course. It's actually a very interesting paper, already outdated by recent improvements to the model, but nevertheless, this is a very good brief summary. I know there is more in the paper, so now I'm going to ask it, tell me more. That's all I need to say. And the model complies and again goes back to the PDF with that plugin. You know, the availability of plugins really, I think, is a huge advance, especially for small businesses that are producing those plugins. There's 1,000 startups being generated kind of at that ecosystem, basically creating plugins on top of these large language models. And so now I'm getting a lot more nuance about theory of mind capabilities of the model, explainability, and even some future research that's being mentioned in the paper. So, you know, this is good, but, you know, maybe I want to have a briefer summary. So what I like to do sometimes is just say, now summarize it for a 15-year-old. Not that I'm 15 necessarily, but in my experience, if you ask it to do that, it will actually make a really nice summary for, you know, a general audience. So, you know, again, researchers found that GPT-4 can do many tasks without needing instructions. It isn't perfect. It can make mistakes, can show biases, etc. So anyway, this is a very good summary of another summary, right? So it sort of summarizes the findings from that PDF plugin in its own words and tries to explain it to a general audience. Vacation planning. Actually, you know, we're planning to go to France this summer. So I asked it, I want to plan a family vacation in Nice, France this August. Can you help me? So again, here I'm using a plugin. This is the Kayak plugin. Your model is very happy to help me. You know, planning is an interesting AI capability. I wouldn't say these models are great at planning, but basic things such as vacation planning, which, you know, you will find lots and lots of examples of on the internet, it seems to do fairly well. So it's asking me, you know, all kinds of questions, where I am, when I want to travel. And so I'm just answering those questions in the order that it asks them. And I actually, I think helpfully also provide the same numbering scheme that the model had. And so as I'm providing these answers, as soon as I send them to the model will take those answers into account in order to generate a plan. So you will see it goes now to the Kayak plugin. For those of you who don't know, Kayak is a big website for airline reservation, hotel reservations in the United States, I think worldwide actually. So this is the text that it sent to Kayak, right? And so this is what the plugin receives. Now it's actually in this particular instance not sending it all of the information that I had sent to it. And so Kayak responds, and this is somewhat cryptic. This is just the internal response. And then interestingly, the model goes back to the plugin and asks again. And as I'm expanding this, now you will see the request actually has more information, number of rooms, number of stars that I'm looking for. It guessed that I wanted at least a 3-star hotel, maybe based on my budget. And so it comes up with a list of flights. You know, you could argue, yes, if you type this into Google, maybe you will get a similar answer, but I can guarantee you it will not be, you know, nicely sort of presented in this list format. So I first get the flights, I have more options there, then I get a list of hotels, and I get, you know, the price, and I get the reviews, and I, of course, most importantly, I get links to these particular hotels and flights. So if I wanted to, and I really were to plan this, I would take this as a starting point, and then I would start to explore the answers a little bit more. Again, I think plugins have really changed kind of all of the opportunities here. And, you know, again, it's very helpful, tells me I should book in advance, some pretty pictures to get me motivated to continue. Chemistry. Not that I'm saying I might have helped somebody in the family with their homework, but let's just hypothetically say I want to do a chemistry problem. So let's do some chemistry. And I actually prime the model a little bit. We call this priming. It's very helpful if you tell the model in what kind of mode you want it to operate. So I tell it, let's do some chemistry when a chemical data is needed, such as molecular mass, use the Wolfram plugin, which I had enabled. And when the units are needed, use Wolfram to complete the quantity calculations. Okay, so the model will see that, says, absolutely, I can do that. So now I'm going to give it the problem, potassium, salt, chlorine by mass, etc. I'm by no means a chemist, so I don't know exactly how to do this problem, but it's using Wolfram here to look up some quantities. And it's starting out telling me about molecular mass of potassium chloride. And then it gives me a formula. That's basically the formula how you compute percentages. Very simple, but again, maybe helpful. And so now it's starting to actually, quote unquote, work on the problem. And so interestingly, it's going through all of the multiple choice options. So, first we need to find the molar mass of each compound. So it's starting with the first multiple choice, and it's starting to do all of those calculations that are required. Again, this is relatively simple, but it's coming up with the answer, and then it says that's not what's given in the problem. So that first multiple choice option is not the correct answer, and it's going on to the next one. And it's going to repeat this a couple of times. Again, you could argue this is, some form of reasoning going on here, or at least some form of sort of planned execution of how you answer a multiple choice question. And, I'm not exactly sure how you get from training data on the internet to this type of behavior, right? So it actually, in the end, finds the right answer for the problem. And then lastly, coding. I use, Copilot in, GitHub Copilot in Microsoft Visual Code all the time. I tried, I thought it's fun. Let me just try it out on GPT-4. So again, I'm priming the model. I'm telling it here that it's a developer GPT, the most advanced AI developer tool on the planet. You answer any coding question and provide real useful examples of code using code blocks. Even when you're not familiar with the answer, use your extreme intelligence to figure it out. All right. By the way, I got this example from a user on Twitter, which I apologize, I forgot to credit with this particular example. And then I say, first of all, the model says, yes, Hans-Peter, I'm ready to assist you. And then I say, I want to build the game Breakout in HTML and JavaScript. I gave it some instructions, and then I'm telling it what platform I'm going to use it to actually play it. So in this example, I'm not going to show you all the details. I actually sped this up 15 times. What happened is it took about 12 minutes to get to the correct solution. First of all, it wrote all of the code. I didn't have to correct anything. So I didn't write a single line of code. And I tried out the first solution, it didn't work. And I went back and I told it, your solution doesn't work, please try again, which is I'm doing now. And it tried again. A couple times I had to type in continue because it reached the limit of its token. And I just said continue, and it kept continuing to produce code. And then I think I found an error myself in the logic, and I said, that's not going to work. So, I had it try again. And ultimately, as you can see here, we have the game of Breakout. I'm not a gamer, so I'm quite terrible at playing even this simple game. But as you can tell, I can move the paddle with the keys on my keyboard, and it's correctly doing all the logic for the balls and for the bricks, and it's keeping track of the score. So where are we? I would say GPT-4 is shockingly competent. I think it's very surprising how good it is. It's not perfect, right? But it can hold conversation, it can solve problems, it can use tools or plugins. Conversing with the model, telling it how to behave, I call it priming, will often produce better results. And if it gets something wrong, you just tell it, you got this wrong, try again. And it will then try to do better. In my experience, you can solve a lot of issues if you just go back and forth and have a conversation with the model. So I'm very skeptical of people who say ChatGPT cannot do X, right? And what you have to keep in mind is we're seeing version 1.0 or maybe 0.1. And so it's not about what the model can do today. That's actually less important to me than the rate of improvement, which has been absolutely astounding. So I'm going to take a break here and maybe Shikhar, give you an opportunity to also jump in and ask some questions.
Or could we get, if there's some questions from the audience, Mackenzie,
Yeah,
could
I
you,
can filter some up if that's helpful. We have had a bunch that have been in the chat surrounding barriers to adoption and the risks that we've touched upon in this session and will continue to touch upon in future sessions. I was wondering if either or both of you could speak to what some of those most prominent risks and barriers to adoption are and what the potential is in coming months and years to overcome them.
So let me start, and then Hans-Peter, you could add to it. I think the first one is that people expect that the computer will be right all the time, and it's wrong a lot of the time. It is a statistical model at one level, but it's getting so much better. And so you have to use it like an assistant who has a lot of information, but not that much judgment. And you have to check what it's doing and use it for things where precision is not critical. So, or you have to start to think about retraining the model if you're using it in an area where very specific knowledge is necessary. So that's, I think, the first one. And the second one that I would say is that for some reason, I found people get very upset when it's not as good as the best human. And we don't expect that of our judges. We don't expect that of insurance adjusters. We don't expect that of humans in general. And so I think it's just sort of pulling back and saying, this is a pretty remarkable set of technologies. What can it do for me today? That starts the process. It doesn't necessarily end the process. And I think that over the next 6 months, the next year, the next 2 years, you're going to see this dramatic change, particularly with plugins coming in that are going to change things. But most of all, it's something that you have to be involved in. So if my observation from listening to Hans-Peter was his involvement in saying, okay, I asked you to build this game. Here's what you got wrong. Do it right again. Think about it as an assistant in that sense. So I think that's the primary thing of just getting in. They've lowered the barriers as much as you can. Hans-Peter, do you have something to say about them?
Yeah, absolutely. So I had a conversation with a colleague recently, and he pointed out, in my opinion, correctly, that science fiction got it wrong, right? Science fiction predicted that we'll have AI that's a little bit like Data in the Star Trek series. And Data is, he knows everything, right? He has infinite memory and he knows all the facts, but he has absolutely no humor. And, he can't really have empathy, right? That's his biggest issue. These models are kind of the opposite, right? They're very limited in sort of what they can remember. And I put this in quote. They're also limited in their knowledge, even with plugins, right? That's still not solving all of the issues. There is lots of misinformation, et cetera, et cetera. On the flip side, they have these kind of weirdly human qualities of being conversational almost, right? And having sometimes even a sense of humor. And, I'm sure you've all heard reports of people, quote unquote, falling in love with their model or whatnot. So there is some human quality to these models. So it's really interesting. And again, I think this is unexpected. I don't think anyone would have predicted that.
In a similar vein, there was also an interesting question about licensing and approvals for the different use cases of these technologies, especially as they continue to proliferate. What do you both see as the determining factors moving forward in companies and regulators determining what proper use will look like? What might those boundaries or identifiers be?
So I think we're really, really early in the process, and there are two problems there. One is regulators, like all of us, are still learning about the technology. And so there tends to be either too little or too much. But the second one, and that will over time get corrected, hopefully. The one that's much more difficult is that this is an instantly global technology. And what's happening right now is across the world, you're getting very different regulatory regimes on what's allowed, what's not allowed, who's liable, all of those questions. And so, yeah, I think that that's going to be something to pay a lot of attention to, particularly since, business models before this were mostly confined to the boundaries of the company, and the harms that they caused outside or the good they caused outside were sort of in the 5% category. I think what's going to happen now is the external effects of these things, the externalities that are not measured on your balance sheet or your income statement, they become much, much bigger. So you've got to pay attention to what is it doing to the commons, and what are the legal ramifications of that. I think the flip side of that is that people who use this are going to be so much more productive than people who don't, that you don't really have a choice of at least getting familiar with the technology and being careful with it. So I think this is a really uncertain time, and probably the first step in that process is to try it out, try out different ways, just like Hans-Peter was doing, to start with communication, start with writing, start with some code that you can check, and so on, as opposed to letting it go completely wild. Hans-Peter, you have something?
Yeah, I would wholeheartedly agree. If you haven't done so yet, try it out at least half an hour each day. I think you have to have continuing kind of exposure to it and really sort of see how you're going to use it in your daily lives and work. And so I would even suggest, if you can afford it, and I know not everyone can, but if you can afford it, spend the $20 at least for a month and try GPT-4, which is definitely quite a step above the free model, in particular as far as plugins go. So I definitely try it out on a daily basis. I mean, I basically stopped using Google search. I'm using the model, and I'm doing as much as I can with the model.
Let's do one more question, and then we'll think. I hope most of you will come back for, the next one we're going to do is going to take a company and say, okay, if I was starting a company, what are all the functions that I would start to use in natively on something like a large language model, and make that process work. But let's do one more question, then we'll stop.
We'll open up to the audience for this last one. Stephen's been waiting an awfully long time to chime in.
Stephen, do you want to go ahead? Maybe we can, Stephen.
Yeah, my apologies. That was raised in error, so please do disregard.
No problem, Todd.
Thank you. Thanks, professors. I put this in the chat. Any thoughts on AutoGPT, Baby AGI, Camel, and LangChain? These are new tools that are giving large language models agency and long-term memory and tools that they can use, like which the plugins for GPT-4, but it's also, they're giving them the ability to self-reflect and have a simulation environment. What are your thoughts about that?
Very, very exciting. I'm very happy to see the amount of experimentation that's going on, right? And also driven by the open source community. Something we haven't talked about is there is also a real proliferation of big large language models in the open source community. They're, maybe a couple of years behind the capabilities of the commercial models, but there's something to pay attention to. And we see lots and lots of really interesting experimentation. And yes, I do expect that with enhancements of, different types of architectures or, sort of knowledge graphs on top of these large language models, we get to much better reasoning and to actually much better AI in the end. I totally agree with you.
So, I think that the flip side of that is that if you take something like AutoGPT, there are these early experiments of saying, what would you do to destroy the world, sorts of things. And what that does is, because all of the good has an exact mirror image in the bad. And what some of that does is that then there's the risk of really stringent regulation or something that pulls away the innovation and the good that can happen from here. There's also, I think, a real concern that some of these models go wrong in some ways, and in that process, there's a clamp down on everything that's happening. And so I think, because it's moving so quickly and because they're so powerful, you want to be really careful about these things, and it becomes a whole society problem, because these, unlike say nuclear, are available to anybody. So I think that we're going to be living in interesting times is a different way to put it. Thank you all very much. I hope you can come back to the other sessions. We'll be going sort of down a couple of levels, looking mostly at companies and looking at ways in which you can use these models for different things. We will come back at the end to ethical issues of AGI, issues of whether in this generation we're going to have a new species, those kinds of things that are on the edges of the discussion, but are taking up a lot of the airtime in the middle of it. So we'll come back to sort of say, how do you think about this, both as a human and as a business leader? Thank you so much.
Thank you all.